In this video, I'm going to give you two classical relativity velocity problems. So to start, I'm going to draw a van on a road. And let's say there's a ball inside the van. Now let's say the van is traveling at 3 meters per second. And let's say the ball rolls backwards at 1 meters per second. So before I get you to solve what's the velocity of the ball relative to the ground, I'm going to give you the formula for the velocity of the ball relative to the ground. So the velocity of the ball relative to the ground is equal to the velocity of the ball relative to the van plus the velocity of the van relative to the ground. So if we want the velocity of the ball relative to the ground, we must plug in velocity of the van of the velocity of the ball relative to the van, which is negative 1 meters per second, because it's going backwards, so it's negative. And it's plus the velocity of the van relative to the ground, which is 3 meters per second. So the velocity of the ball relative to the ground is just equal to 2 meters per second. Simple, right? Now I'm going to give you another problem. Let me erase all of this. Let's say there's a van that you're looking at from above the ground, and it's driving on the road, and there's the ball again. Let's say the van is moving forward at 3 meters per second, and the ball rolls to the right or to the left at 4 meters per second. What is the velocity of the ball relative to the ground? Now, if you remember, I said that the velocity of the ball relative to the ground is equal to the velocity of the ball relative to the van plus the velocity of the van relative to the ground. So in this case, we're adding vectors that are orthogonal to each other, right angles to each other. So let me make room here. So we have a vector of 4 meters per second. We have a vector of 3 meters per second. If we want to get the velocity of the ball relative to the ground, we have to add the velocity of the ball relative to the van plus the velocity of the ball of the van relative to the ground. So that's 4 meters per second plus 3 meters per second. But the directions is at right angles to each other. So we add them tip to tail. We have 4 meters per second plus 3 meters per second, which gives us a velocity of 5 meters per second. And that is the velocity of the ball relative to the ground.